All right, well, I'm back. Hope you are too. Hope you got through translations okay. If you didn't, please go email me or send a Hangout invite for help, and I'll be glad to help you out with those. We want to try to make sure you get help on these things before it gets too out of hand, because we are going to do multiple transformation sequences at the end of the topic here, and that's going to be a little bit more involved. So make sure we get the individual ones, we understand those first before we add more to it. Okay. The next on the list is a reflection, and a reflection is basically a mirror image. Okay, it's when a figure is flipped over a given line. That line is called a line of reflection. On the coordinate plane, we'll talk about this in a few minutes, that's an axis. It's either for us the x-axis or the y-axis. It can be any line on the coordinate plane. We're just going to make it simple and just make it the x-axis or the y-axis. Okay? Just like translations, reflections do not change size or shape, so they produce congruent images. Okay? And they do not slide or turn. They just flip. Okay? So in each case, for the first example here, I'm going to have you look at both of these. And I want you to tell me if either one of these is a reflection. A figure 2 is a reflection of figure 1 over the given line. So here's the given line right here. And here's the given line right here. These are your lines of reflection. Okay, so you need to tell me if figure 2 is a reflection of figure 1. I'll pause for a minute and let you guys figure that out. Okay, so for figure A, or for problem A, you should have said yes, because that figure 1 flips below to become figure 2. But for figure B, the answer is no. That is not a reflection, because if you notice, that's a translation, because the figure didn't flip. If it flipped, the pointed end of the quadrilateral would have been over here on this side, and that's not what happened. So figure 1 just slid over to figure 2. It did not reflect over that line. Okay? So there is our introduction to reflections. For the discussion question, does a reflection produce a congruent final image? Yes, it does. We just talked about that. Does not change size and shape, does not slide or turn. So it does not change size or shape. That produces a congruent final image. Okay? Let's talk about reflections on the coordinate plane. So again, we're going to start with the point 1, 3. Okay, it's going to be our pre-image. So I got that point plotted there. Okay, we'll highlight as we go along. Okay. So as I talked about before, over here in bold print, okay, the x-axis or the y-axis are the line of reflection. Okay, so that's important to know. In fact, we're going to reflect, on part 2, we're going to reflect the point over the x-axis. So we are going to make the x-axis right here line of reflection. In fact, I'm going to shrink that down just a little bit so it doesn't take up as much highlight. Maybe just a tad more. There we go. Okay, so what I would always do on the coordinate plane is mark your reflection line, because so many times students miss reflections because they reflect over the wrong line. Okay, so if you reflect, you might get the right reflection, but you reflect over the wrong line, I can't give you full credit for that. So if you would just reflect it over the correct line, the way to remedy that is to mark which line you're supposed to reflect over. Okay, remember, this is the x-axis right here, and this is the y-axis right up here. Okay, so make sure you reflect over the correct axis. So we're going to take that point and reflect it over the x-axis. Now for this to work, you have to determine the distance the point is from the line of reflection. So if I count, the point is 1, 2, 3 units away from the line of reflection. So in order to reflect the line reflect the point properly, I have to move it 3 points on the other side, 3 levels on the other side of the reflection line. So 1, 2, 3, just like this. Do that one more time. There we go. All right. So my point is going to be right there. your pre-image and your final image must be the same distance from your reflection line. So if it's 3 levels for the pre-image above the line of reflection, then my final image has to be 3 levels below. Okay? So I have my new final image. So the coordinates of that point, 1 to the right, 3 down. That's going to be the point 1, -3. Okay? So now on part 3, we're going to reflect this point over the y-axis. Okay, so I'm going to mark the y-axis. There we go. And get ready to do the reflection on the other side. So if you notice here, okay, we're going to see how many units it is away from the y-axis, and it's 1 on the right side. So in order to reflect it, I got to move it 1 on the other side. So then it's going to be right there. Okay, and I just did a reflection over the y-axis. So I've done a reflection over the x-axis, now I've done a reflection over the y-axis. Reflections are pretty straightforward. There's really not much trouble with reflections. So let me do that one more time here. There we go. All right, so according to the point, count it up. -1, 3. Okay, so we've done reflections over the x-axis and the y-axis. The only thing that we have to make sure we do is just keep these intact, okay? So we're going to answer these discussion questions here in just a minute. Actually, the answers are on the next page for you. There are symbolic representations for these, okay? And the symbolic representations are, for the x-axis, it's x comma opposite of y. So if I go back up here, okay, and compare the point 1, 3 to the point -1, -3, notice that the y coordinate became the opposite, okay, from when I did this one to this one. All right, the y coordinate became the opposite. +3 right there, -3 right there. And then likewise, when I did the reflection over the y-axis, okay, it is the x-coordinate is the opposite. And remember, we want to make sure we say the opposite, not negative, because if our value is negative, it doesn't necessarily mean it stays negative. It becomes the opposite of. So that's a misconception a lot of students make, is that negative just always means negative. No, it doesn't. That's why in class I try to emphasize negative signs mean opposite of. Okay, and that couldn't be any more truer than right now, because now we're talking about the opposite of x, the value of x. And as we look at from and compare step 1 to step number 3 here, okay, +1, and it went to -1. Okay, so that's how the symbolic representation works. I'm going to let you do example 2 on your own. Okay, I'll plot the pre-image with you, and then I'm on pause and let you reflect this shape, this pre-image, over the x-axis. Okay, so we'll get that set up for you. Okay, there's the x-axis. Mark it so you have it marked, so you know which one you're marking or reflecting over. And we're going to start plotting these points here now. Okay, it's a parallelogram, which is a special quadrilateral, 4-sided figure. So -1, -1 is the first point. That's point A. Okay, and then I have 2, -1. That's point B. C is 4, -3. So 1, 2, 3, 4, 1, 2, 3. Okay. I'm going to move this B out of the way. It's in my path of trying to get my side there. So, and then D is 1, -3. So it's going to be 1 there and then 3 down, which is the point right there. So this is C. That's D. connect your points together, get your parallelogram. Okay, and then reflect that parallelogram over the x-axis. Okay, I'm on pause for a second and give you a chance to try that on your own, and then I'll tell you the answers in just a minute. Okay, so if you did it correctly, A should have come up here. Okay, that's 1 away, so that should have come up there. So the new points of A are -1, 1. The new points of B, again, 1 unit away, okay, from the line of reflection. So it's going to become the point 2, 1. Okay, and C was 3 units away, so it needs to be 3 units away on the other side. That's going to become the point 4, 3. And then D is also 3 units away. So that's going to become 3 units up on that side, so it's going to become the point 1, 3. And I have my reflected parallelogram. Okay, so this is A prime, B prime, C prime, and D prime. And this is that parallelogram right there. So that's example 2. Now example 3 is a triangle. I'm going to have you guys do this one on your own. I just want to talk to you real fast about, we'll plot the pre-image, and then I want to talk about the transformation. I'm going to have you finish it up on your own. So we'll plot the pre-image first, and then I'm going to have you guys actually do the transformation on your own time. You can check it with the answer key. So 1, -2 will be the point A down here. 4, -2, 1, 2, 3, 4, 1, 2 will be the point right here. And then 1, 4, 2, 3, 4 will be the point up here. So this is a triangle, right triangle actually. So I have point A, point B, point C. Okay, and then you need to figure out what reflection to perform using this notation and perform it. Okay, I'll pause for a second, and then I will come back with you and we'll go over the answer together. Okay, so here's what I suggest that we do first. Let's mark our line of reflection. So if you notice that this had the opposite of x in it, that is over the y-axis. So we're going to mark the y-axis here. Oh, I want to change that down just a little bit so it doesn't cover everything up. Okay, close enough. So now we're going to start reflecting it over the y-axis. Okay, so zoom in here real big so I can get it figured out here. 1 unit away. 1 unit away for A. B is 1, 2, 4 units away. So 1, 2, 3, 4 units away for B. C again, 1 unit away, 1 unit away. Okay. There you go. There you go. Okay. So this is A prime, B prime, C prime. Let's get order pairs. You can use this notation here to get it. You can use your symbolic representation and just change every x coordinate to its opposite. So it's real fast. Okay, so it'll be -1, -2 for A prime, -4, -2 for B prime, and -1, 4 for C prime. Okay, so that's example 3. All right, in our last example, again, I'm going to say one of these for you to do. So I wanted to show you, I'm going to help you out with A, I'm going to let you do B on your own. But for A, I wanted to show you what happens when they cross the line of reflection, just for a minute, because that can get kind of tricky, okay? So in each case, determine the transformation on figure 1 to obtain figure 2, okay? So I'm going to give you a second to try to figure it out on A and on B, okay? We're just going to focus on A here for a minute. So just focus on A for a minute so you can figure out the reflection, okay? And I just told you it was reflection, of course. So reflection over what axis? So you can figure that out. Pause for a second. Indeed, it is a reflection over the y-axis. Okay? So how do we know that? Because if you look at the points, okay, and again, we want to do this for one point, so I like to focus on A and A prime. So if you notice, A is 3 units away, and A prime is also 3 units away from that line. Okay? So this is definitely a reflection over the y-axis. It's not a reflection over the x-axis, because if it was a reflection over the x-axis, A prime would be up here in this vicinity somewhere. So that's not happening. Okay, so it's a reflection over the y-axis. Okay, and I assume you can figure out what B is now relatively quickly. I'm going to go ahead and give you a chance to figure that out just for a second. Okay, yeah, I'm probably guessing that it's a reflection over the x-axis, but there's one thing here that I want to talk about on both of these. Okay, and that is on A. Notice that the figure doesn't have to be contained in one quadrant. Reflections work regardless. So if you notice, A went over here A went from left to right, okay, like this. But look, B went from right to left, and C went from right to left, okay? That's okay. As long as you still reflect the shape correctly, it's okay. It can reflect and can be kind of reversed like that. That's fine. Over here on problem B, notice that A prime in A and B prime in B are the same point, okay? Well, the reason why that is the case is that since they're both on the line of reflection, which is the x-axis, okay, they are 0 units away from that line of reflection, so they remain 0 units away when they've been reflected. Okay, that's going to do it for reflections. And in the next video, we'll talk about